So today we're here at the exercise facility where the astronauts come out and train on some of the equipment that's on board the space station. And here with me today we have Lori Ploutz-Snyder. She is the lead scientist for exercise physiology and countermeasures. Welcome, Lisa. Thank you for coming. First of all, we were going to talk to you a little about a study that is currently ongoing. I believe it happened once. Started with a crew that is now down, and they're also participating in this study now. That study is called SPRINT. And so first, just talk to us a little about what SPRINT is. Give us a brief overview, if you will.
SPRINT is an exercise research study that looks at an integrated exercise program using aerobic and resistance exercise. And we're trying to come up with the most efficient exercise prescription to optimize the cardiovascular system, skeletal muscle, and bone. And it builds off of about 2 decades of previous NASA research evaluating individual systems, and for the first time is trying to bring together an integrated program to develop the best countermeasures for overall fitness.
That's a mouthful. And so explain to me exactly what specifically is the crew doing, what kind of activities are they doing that would be different from what their normal exercise program would be?
Yeah, there are 2 main parts to the SPRINT program. The first part is a set of ground-based tests before and after flight to provide a really thorough assessment of the cardiovascular, muscle, and bone systems. And so these include maximal aerobic testing, different muscle power, muscle endurance, muscle strength, variety of muscle performance tests, a muscle biopsy, as well as measurements for bone, including QCT and DEXA. And so with these measurements pre and post flight, we'll get a really thorough assessment of the crew's physiologic function. And the second part of the study employs an in-flight component where they perform a new exercise prescription on ISS. They use all of the same ISS equipment, but the way the exercises are prescribed is a little bit different. So we include aerobic intervals, and that's how the study got its name, the SPRINT. So they do some sprinting on the cycle and the bicycle, where they go at high intensity for short bouts and then have a rest period. And we also have resistance exercise on the ARED that they perform 3 days a week.
Okay, so currently the crew is exercising 2 hours every day. Will that change with this experiment? Are they resting any time?
Yeah, this experiment is evaluating a higher intensity exercise prescription that can be done for shorter amounts of time and less frequently.
Now, so are they more worn out the next day? I mean, they're going to have this rest time, but they're actually, basically what I'm hearing from you is that there's a more intense workout. So is it problematic at all on the rest period?
Well, so far it's exceeded our expectations, but we've only had 1 person complete the study, but so far it seems to be working really well.
So far we have positive data. Now, so one of the crew members who actually did this study is down, and we can't talk about personal data, but can you share with us if there was positive data from that study?
Yeah, he exceeded our expectations, and it went very well, especially for the first person, both in terms of the implementation. There's a lot of new communications necessary in this study. One of the things I didn't mention before is that another novel part of the study is we evaluate how they're doing during their whole mission. So every 30 days they perform VO2 max tests, which tests the maximal aerobic capacity.
That's that thing Lance Armstrong is really good at, correct?
That's right. One of the things. And we test that every 30 days so that we can keep an eye on their aerobic fitness, and then we can adjust the prescription as necessary, up or down, depending how they're doing. We also have, for the first time, measurements on ISS of muscle ultrasound. So we're using the new ultrasound system to make measurements of the leg muscle size, and the crew members scan themselves and make measurements of their own muscle size, and we compare that with the loads they're doing on ARED to determine how well they're doing for the resistance exercise, and we can adjust the prescription accordingly. And so this involved a lot of new implementation of communications to get this data quickly and coordinated. So both from the implementation standpoint and from the performance standpoint, our first subject was a great success.
Awesome. Well, so first let's go ahead and talk about some of this equipment that we have. I understand there are 3 main pieces. We have One right here behind us, this is the Advanced Resistive Exercise Device. And what other pieces of equipment are you using during this study?
So all of our resistance exercises are performed on the ARED, or the Advanced Resistance Exercise Device. There's also a treadmill and a cycle up on the space station. And in the sprint program, the participants exercise on both of those, at least 2/3 of their aerobic exercise on the treadmill. So a little more treadmill than cycle.
Okay, great. So we know what the cycle is and a treadmill is, but the advanced resistive exercise device basically is a piece of equipment that simulates weightlessness here on Earth. Thank you very much for coming by and talking to us about the Sprint study.